Good afternoon. It's really awesome to be here today. I am presenting on Project Pithia, which is an NSF EarthCube funded project, which is really comprised of several people, several of whom are in the room along with me today. The lead organizations behind Project Pithia are NCAR, Unidata, and University at Albany, where I reside. So much of the talk, or at least the last 2/3 or so, ideally, is going to be a tour of what we have developed on our website for Project Pithia. But I'd like to kind of step back, literally, but not too far. That step is a little scary. So I want to talk about how I got to where I am in the Python ecosystem, starting about 10 years ago. 10 years ago to this date, if someone were to say, well, in 10 years, Kevin, you are going to be at a scientific programming conference in a language that you've never heard of, I'd be like, okay, I'll talk to you later. It's not going to happen. But I want to talk about 10 years ago this week, specifically 2 days prior, so July 11th, 2012. Among other things, the #1 song on the top 40 charts here in the U.S. was Carly Rae Jepsen, Call Me Maybe. And when I was looking up the information for that particular day and what happened, it actually said, kids, ask your parents about this song. And God, that made me feel really, really old. But really more important than the top 40 charts for me is that on July 11th, 2012, it was the first day of every 3 years triennial workshop for an organization that I've been affiliated with for a number of years, Unidata, which is co-located with NCAR in Boulder, Colorado. So we hosted a workshop which was entitled Navigating Earth System Science Data. And at that particular workshop, Daryl Hersman, who's at Iowa State University in their meteorology department, he demonstrated what was called the IPython notebook. We know that today as the Jupyter notebook. This was the one and only Python talk at that particular workshop, and it was really the first time I had heard of Python. And when I saw the interactivity, the browser-based interactivity that Daryl showed with the IPython notebook, I was like, this is the most cool thing, and I really want to get to know more about Python and how it may have impacts on the geosciences. So let's step forward 3 years. I mentioned that the Unidata Triennial Workshop, triennial every 3 years. 3 years later, I co-chaired the 2015 workshop, which was called Data-Driven Geoscience. So the curve of 0 to increasing adoption of Python in atmospheric science was rising fairly nicely, 1 to 5. Hey, that's 500%. At that particular workshop, there were several packages that we all know and love. It was the first time that I had heard of X-Array, for example. At that point, it was called X-Ray, since been updated to be called X-Ray not too long after that. Another 3 years later, this time not talking about the Unidata Triennial, because I actually was here. It was my first SciPy. And in that time leading up to it, IPython Notebook had transitioned into the Jupyter Notebook. And as it became more and more popular and more people wanted to use it, there needed to be some infrastructure. So say a department such as mine it would be easier for folks to start working on a Jupyter notebook without having to kind of download an entire Conda environment onto their own system. So leading up to that conference, I had deployed our first Jupyter Hub instance at UAlbany, which is incredibly busy day to day over the years. But at this point this week, I was at the SciPy conference right here in this building. And so we talk about one Python talk in 2012, 5 Python talks in 2015, a little bit of an apples to orange comparison because it's not just a Unidata conference, but hey, the number of Python talks at a SciPy conference, it's not 1, it's not 5, it's all of them. Also at that conference, there was a Birds of a Feather session, and this was the first introduction for me of a great project called Pangeo. And let's talk a little bit, I'll talk a little bit about Pangeo in just a minute. But going forward with the timeline, I'll talk a little bit about an online atmospheric science data analysis and visualization course that I developed. But also, just as COVID was starting to explode across the world, a bunch of us kind of inspired by the Pangeo project and also realizing how much the geosciences really needed to kind of come together in a common platform so folks could maybe more easily start to learn about all of the exciting packages in the scientific Python software ecosystem. We got this project funded, and then COVID-19 hit, and we met online for the next 2 years. But still, good progress was made in the last 2 years. I'm going to be talking about some of the core components of Project Pithia and taking you on a tour very shortly. Project Pithia Foundations and also our external resource gallery. Those were our 2 major milestones that we developed last year. And then, hey, 2022, here we are back in person. How great is that? Well, 2 weeks ago, it's been a summer of travel for me. First work trip in 2.5 years. A bunch of us got together in Boulder, Colorado at the NCAR Mesa Lab, and it was really our first in-person team for Project Pithia, and we then started working on kind of our next milestone for Project Pithia, which is called the Pythia Cookbooks. And as we will see, the cookbooks kind of expand on beyond the core scientific Pangeo-esque ecosystem. So I want to talk a little bit now about where I was in 2020. So in addition to kind of spinning up Project Pithia, I was also tasked with developing a new class in my department at UAlbany. And essentially it was, how can I teach the Pangeo Python software stack to our senior students and incoming graduate students? Inventing a new course from scratch for all of the educators in the room, never an easy task. And at that point, I was kind of faced with the common conundrum: where do I find all of the information? Where do I find all of the data? And for me, it was just a bunch of Google searches, but you really can't teach a class with just a folder in your Chrome bookmarks with links to all the web pages. There's got to be a better way. And that better way was started to made clear to me via the Pangeo project. I know Ryan Abernathy is going to be talking about the Pangeo Forge later this week. So I encourage you to all check out his talk, but just a little bit of background on Pangeo. A lot of times people think Pangeo is just another Python software package. Well, no, it's really a community, not a software packages. It comprises a bunch of the Python software set stack, many of which that we've been talking about and hearing this week. So Project Pithia focuses on the educational outreach, if you will, of Pangeo. So, moving on. So, let's talk about all the various questions that one has to face if they are developing a new class in advanced Python data analysis and visualization in the geosciences. So 5 core questions. One motivation. At first, there was maybe a little bit of pushback in the department. Why do we need a programming class? Isn't Fortran good enough? If you're a meteorologist and you're doing modeling, just use Fortran, right? Well, at AMS, one of the AMS annual meetings a few years ago during the career fairs and the student conference, when students were meeting with the prospective employers, they found that the prospective employers wanted core skills that were not being commonly taught in a university atmospheric science curriculum, specifically programming with Python. Python had become well established outside the bounds of a university department by that time. And also the ability to work with large and increasingly large data sets. So NSF sponsored 2 workshops called Mind the Gap. We actually just had our second meeting at UAlbany last month. But from the first workshop in 2019, one of the main takeaways was that educators in geoscience departments need to update the curriculum. For a meteorology program, having a curriculum that just trains students to get jobs with the National Weather Service, as important as the Weather Service is not sufficient. So, once again, how can we put together a community-type effort that is going to make our jobs, my job as an educator, students' jobs as students soaking up this material, how are we going to make that easier? So, take again, all of us, many of us here may have given a tutorial on some aspect of Python. Maybe that's a 13-week class like mine. It may be a few days. It might just be part of a day. With all of the huge ecosystem, it may seem like a hopeless task. And I went through many struggles trying to put together an effective syllabus when I was developing my class in 2020. So we have seen versions of this slide all through this week, and we'll see more of them. We know that the software stack in Pangeo is very large, and I mean really, really large. And it's just getting bigger. By the way, I saw Rich Signell yesterday wearing a Dask t-shirt, and he said, that's the old logo. And I realized, oh my God, I've got the old Dask logo on this slide. So there, fixed it for you. All right, and hey, this ecosystem is getting bigger every hour. So 1 hour ago, Julius just presented on XMIP. So here we go. Here's another part of the puzzle that we have got to integrate. I mean, it's super cool. We want to have our students, our researchers, be able to quickly find these tools and learn how to apply their workflows to them. So, large stack, but one of the decisions that we made early on with Project Pithia is let's start with the core foundations. That includes software packages such as Xarray and Cartopy and Matplotlib, but it also involves using Jupyter. So we're going to be using Jupyter Notebooks or Jupyter Lab. We are going to be using GitHub to serve our content and build not only our foundational site, but also our resource gallery and our cookbooks that we've just debuted. And of course, it's all based on Python. So for this foundation, Project Pithia was formed. And hey, let's actually make this look like a foundation. So here we've got, once again, our foundational structures, our 3 foundational structures at the bottom, supporting this core geoscience, Pangeo software ecosystem. Suddenly now, there is a road forward, and maybe our mission, Jim, will actually not be impossible. All right, so That's the why and a little bit of the what. How are we going to do this? And here we're going to talk about infrastructure. We've got to be able to deliver the Jupyter Labs. We've got to ideally make it possible so someone who is at an institution or maybe just learning on their own doesn't need to roll their own Jupyter Hub like I've been able to provide at UAlbany. Well, we need this open source software infrastructure. If you were at the keynote this morning that we saw from Ben, he mentioned this open source software infrastructure. That's what powers Project Pithia. As Fernando Perez said last year, it's a foundational public good. And as Ben mentioned this morning, it is foundational research infrastructure. That's what supports Project Pithia. So where is this going to run? Well, it will run on your laptop. It will run in your university lab. You can actually download I hate to use the term download, you can do a git clone and get everything running on your own device. But we also want to make this, we want to take advantage of the physical infrastructure that we may have available. So there are efforts beyond just the web-based content in Project Pithia. We also want to have some hardware infrastructure to deliver Jupyter Hubs, specifically using Binder on HPC systems, so at NCAR Cheyenne, and then also in the NSF Research Cloud, the newly deployed Jetstream 2 is where we are focusing efforts, besides Cheyenne, to deploy a Binder hub. So, okay, that is a little bit of the lead up to Project Pithia. So let's jump to the website and let's take a little tour. So the website itself, projectpithia.org. So let's take a look. So the foundational content here, it is all delivered, talking a little bit again about some of the infrastructure. The content is delivered via the use of JupyterBook. So we have several parts of our foundational content, not just including the core software packages, but we also have introductions to using just Python itself, Jupyter and Jupyter Notebooks, and also, since Git and GitHub is such a core skill, we have lessons on getting started with GitHub. Let's take a look at one of the core packages. So we've got CartaPy here, and if we go into our introduction to CartaPy, what we have is, in this case, one particular notebook. Once again, the beauty of JupyterBook is that it's executable content. So we have a notebook with CartaPy that we've already we've already run. So it's already fully rendered. So we could actually use this particular chapter of this particular foundational content in Project Pithia to kind of be used as a textbook, but we also provide several other ways to interact with the content. I'll show Binder in just a second, but we can also go directly into GitHub. You can check out the repository. You can open up an issue, and you see something that isn't quite right on any of our Markdown-enabled notebooks. You can suggest a page. But the Binder link is a way that we can just kind of spin up an instance on the My Binder cloud, and this may take a minute or so, even though we've deployed this. I've run this notebook before, but this will at least give folks the ability to then step through and run the notebook interactively. And in this case, it's fairly snappy. So here, once again, now presented as an interactive Jupyter notebook, one can step through the content. like to also take a look at our resource gallery. This was probably the first thing that we presented on Project Pithia, because we already knew there was a lot of great external content out there. So we actually have a searchable set of external resources. There are many of them that you could scroll through, but the neat thing about this site is that we actually have the ability to kind of pick and choose not sure what's happened there. Sorry about that, folks. We can actually choose and subset. So if you're interested in climate, you can bring up just a particular link to a external resource for that topic of interest. And then I'll also just mention a little bit our latest effort, cookbooks. This kind of now goes beyond the core content and starts reaching out into the wider Pangeo ecosystem. And so one of the efforts that we spent some time on a couple of weeks ago was starting to move some of the CMIP6 notebooks that have been hosted on the main Pangeo site. And so that is one of the examples there. And again, kind of works the same way. You can bring up the notebook directly, or you could actually launch and run through it using Binder. So just a bit of a tour of the functionality there. But the main power of an intent of Project Pithia is this is a community-supported site. I mean, we really want to make this a resource that's available to all. Instead, even though there are great sites, like for example, Julius, we can just go to his XMIP site and interact with it that way. What ideally we would love to have, and what Project Pithia aims to provide, is a way for folks to kind of contribute their own content. We have some core CMIP6 notebooks in our cookbook. It could be really, I think, approachable for one to just contribute a new notebook on CMIP6, perhaps then also exposing, say, the XMIP package that Julius just demonstrated to us. So we also are an open community, much like Pangeo. We meet every week with our three main working groups: an education working group focused on the content, infrastructure, main task these days, trying to get Binder Hub working on HPC and Jetstream, and then an outreach group where we try to reach out to folks like you in the community. So sorry for the AV technical issues there. Unfortunately, that's not something that Project Pithia is able to solve just yet, but we'll be around. There are several folks here in the room from Project Pithia. Maybe if you could just show your hands if you're involved with the project. Very happy to meet and talk. I think we'll all be, or at least several of us will be at the Pangeo Birds of a Feather later on Friday. So that is all I've got. I encourage everyone to check out and contribute to Project Pithia as it continues to develop over the next couple of years. Thank you.
Awesome. Thanks so much, Kevin. If people have questions, go ahead and put them in the track questions-room-204. We'll go ahead and relay those questions on. So the first question is, how does this interact with 2i2c.org?
Great question, and we love 2i2c.org because actually at our hackathon, they very kindly were able to provide a Binder Hub instance for us. So one of the frustrations that we've had, even though the Binder service is great, it's so great that it's very popular, and it sometimes can not quite support the number of users that wish to kind of use its resources and run some of the complicated, deep software ecosystem heavy projects that we have. So 2i2c, and we're interacting with them to get some tips as to how we can deploy Binder Hub on HPC and on Jetstream.
Yeah, they also added that stellar work, so shout out. Next question. So there seems to be pushback from students, researchers, new Python users on learning GitHub and Jupyter along with Python, with the thought that it is overwhelming when starting out. How do you get students to buy into using these resources from the beginning?
I think a good resource, a good strategy is simply, I love how Software Carpentry poses it. They have an XKCD cartoon. You just kind of show first of all, the importance of version control and what it can do for you, instead of having, thesis.1, thesis.2, thesis.2.save, etc. Ultimately, with just a little bit of buy-in, you end up, I think it's especially attractive to new students. You catch them before they become acquainted with the Linux command line. So instead, before they start knowing how to navigate the Linux file system and copy files and remove files, how about just doing some git adds and git commits? Yes, it's a little bit of a load. And actually, I spend the first 2 weeks of my online class getting folks acquainted with Git and GitHub, but it's where the community is, and what a great way for students to have sort of a modern era CV by having a link to their work on their own GitHub page. So great win-win for the community and for employers.
Great. Next question. Did you encounter any pushback in regards to the security of hosting interactive notebooks? If so, did you assuage those concerns?
Well, one of the nice things in a small department such as ours, where we have a dedicated IT person with root access, is, hey Kevin, I want to deploy a Jupyter Hub. Okay, Kevin, yeah, I'll do it for you. It's a great idea. I was fortunate enough to have a fairly good relationship with our university's information security officer, and very early on, way before Python and Jupyter, just using, for example, Unidata's local data manager. It's like, what's this port 388 traffic going that's flooding the university with traffic? Kind of just made it clear, the importance in a research academic setting that you want to make your data open. You want to share the data. Obviously, you don't want to put your personal identifiable information on your GitHub page, maybe.
Great. Next question. So, how are you engaging with the various geoscience disciplines to build on Project Pithia versus a proliferation of analogous, more discipline-specific resources?
I think really that's a great question. I think the best strategy is what our outreach group is trying to do. First of all, appear at conferences such as this. There's a lot of core members of Project Pithia with a background in atmospheric science and meteorology. We obviously need to continue to expand beyond that. Oceanography is obviously kind of an easy lateral step, but going further into, say, solid Earth geosciences, that's yet another reach. But I think the only way is to continue to expand awareness of our project, especially, say, at larger geoscience conferences such as AGU.
Alrighty. And then for the sake of time, we'll go ahead and take one more question here, just so everyone has a chance to take the break. There's food out there, so this is the last question. In addition to the public Zoom meetings and conferences, has any additional work been done to make departments at other universities aware of the resources available through Project Pithia?
Yes, so one opportunity was just a couple of weeks ago at this Mind the Gap workshop. I was actually really happy to hear that not only many of the university atmospheric science faculty had already heard of Project Pithia, but I was even more pleased to see that many of them were already on the Python and Jupyter train, already have notebooks and repositories of their own that they have in their classes. What a great opportunity now to have them share their great content with the community at large.
Great. So with that, thanks so much, Kevin. Awesome presentation. If you have additional questions for Kevin, go ahead and follow up in the Earth Geo track chat. So thank you so much, and put your hands together one more time for Kevin.
Thank you.